All right, I'm just gonna get started with AOC, and if I hope that somebody will let me know if something's completely off the rails with the stream. I can see the chat, so we'll get by. All right, advent a code. I don't know. Okay, apparently I haven't been here since last year. Day one. All right, so my plan is to do day one, part one and part two, and then go and look at the Clojure solutions in Nash. I mean, in Clojurians, uh, and then try and do day two. Hopefully, this won't take very long. We're still early on, so let's try and get through both of the part of the days. I don't know what next week's going to look like. We're just going to kind of roll with it. All right. So let's read through this. Chief historian. I mean, I think it's okay if we skip like all of the pros, right? Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Throughout the chief's office, the historically significant locations are listed not by name but by unique number called the location ID. To make sure they don't miss anything, the historians split into two groups, each searching the office and trying to create their own complete list of location IDs. There's just one problem. By holding the two lists up side by side, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. For example, okay. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list, and the second smallest in the left with the second smallest in the right. Okay, so sort the two lists and compare them like a zipper, right? Within each pair, figure out how far apart the two numbers are. You'll need to add up all of those distances. So the diff of each, okay? For example, if you pair up a 3 from the left list with the 7 on the right, it'd be 4. Okay. Okay, so I think I have enough to just try this. Okay, so we have the example. I always start with def and test input. This is my test input. Oh wait, do I have a REPL started? No. If anybody wants me to walk through slower what I'm doing, I'm more than happy. This is supposed to be a learning thing, just showing off what Clojure can do and how somebody who's used Clojure for a long time does things. So happy to walk through my setup, what I'm doing, kind of slowly talk through things, and happy to kind of speed along, just if you want to get the action going. But I'm going to start a REPL, and then we're going to connect to the REPL in my editor, and then we're going to define a parse function. Parse takes a string always. Stir split lines. And then we're gonna map over. Let's do transducers. Transducers are the new hot. This is the line. How are we gonna do this? Find. There's some digit, right? Some digit, followed by some white space, followed by some other digit. And we want to capture the two digits. Let's look at the test input real quick. Oh wait, I'm not logged in. I do GitHub, right? Okay. Let's look at the actual input to make sure they're all integers. They are all integers. Do I need to make my screen, my font bigger? Can y'all see? I'll make it. This doesn't look too bad to me. I'll make it a little bigger just in case. Boom, boom. Okay, maybe a little. All right. Hopefully that's better. Let me know if I need to go any bigger. Okay, so we're gonna already find on that L. So let's take an example real quick and run this. This doesn't need to be a def in, that's a def. So it'll be, we think that input text is going to be like 3 space 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 4, right? Oh, load the namespace. Right. And so we get the full match here on the left, and then 3 followed by 4. And if I did like 35 and 42, it does capture the full digit. This looks correct. Right, so the easiest thing to do here is to let the whole thing, the left and the right, I don't know, maybe the L and R, L is used twice, A, X, and Y. Parse along the X, parse along the Y. Okay. Decision point. What are we going to return out of here? Probably let's just start with a hash map. What are these things called again? The lists. Okay, groups. Group 1 and group 2. Group 1 will be this one. Group 2 will be this one. We'll go ahead and rename this to G1 and G2. Okay, so I should be able at this point to parse my test input. Oh, after I def it. Does that look right? 3, 4, 2, 1, 3, 3, 3, 4, 2, 1, 3, 3. Okay, easy peasy. Let me know if that doesn't make sense. I can walk through any part of that again. All right, now part 1 of the input. Assuming that we have this parsed input. We want to sort this list and sort that list. Okay. So we want to map the input to group 1. See what group 1 said. Sort. Yeah, we can just straight sort it, I think. And then we want to map over the results of those things. In Clojure, you can map over multiple lists at one time, and it'll call your mapping function with 2 arguments. This, like this, right? And we want to find the absolute value of the difference, it looks like, right? Because if you pair a 3 from the left with a 7 on the right, it's a positive 4. If you pair a 9 on the left and a 3 on the right, it's a positive 6. So it doesn't matter if the left is greater or lesser, it's still a positive number that you end up with, right? So it's the absolute value. Ooh, we can use Clojure's new. No, there's no abs. Wait, no way, there's no abs, right? Am I? Wait, math abs. Right, math abs. But there's no math abs? Clojure.math. What? Really? I wonder what the rationale for that was. Huh. Okay. Oh, is there already one? No way. Are you serious? Okay, 1.11. All right, all right. I'm not crazy. Like that is new. Okay, okay, okay. All right, the abs of G1, G2. Oh wait, the abs of the difference of G1 and G2. Great. All right, let's see what we got there. Part 1. Thank you, K10. 210125. 210125, and then you sum them. All right. All right. I have a helper namespace. I've been doing this for a number of years, right? I have since 2015 going in here. So we can just util sum this. And we got 11. All right, and which is the practice number. What is the total distance? All right, so here we go. We're gonna do the whole input part 1 of parse the whole thing. 189772. All right, moment of truth. Team, how do we do? Submit. Hey, easy mode. Day 1 is great. Wait till we hit day 2. I'm sure I'm gonna mess this up. Okay. Your analysis only confirmed that they fear the two lists are indeed very different, or are they? The historian can't agree which group made the mistakes or how to read most of the handwriting. A lot of IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. We'll make a similarity score. We're going to add up each number on the left after multiplying it by the number of times that the number appears on the right. Okay. So we're going to say, okay, we have a 3, and that appears 3 times on the right, and 3 by 3 is 9. Is that what it says? Yes. Okay. All right. I think I can do it. Defin part 2. So we get a parsed input. Wait, is it going to do it? Okay, so each time you hit it, so we could memoize that. Let's just start with recomputing it and see how we do. Because we're day 1, we shouldn't have to optimize too much, right? Okay, so we just need to, for each number that we hit. So we want, what do they call it? Similarity score. We're just going to call it right. We want to frequencies the map a group to then, right? So does everyone know what frequencies does? Raise your hand if you don't know what frequencies does. Oh, my head is blocking the code. Get out. My fat head. Hang on. I gotta first figure out how this stupid thing works. All right. Video capture. What if I just hide my head? Oh wait, I have to unlock it. There we go. No. Undo. Oh man, that sucks. Up here? I feel like up here is better. It's odd, but most of the action happens down here. You don't need to see all the REPL things, I think. Okay. Lock. Try this. You also can't see the chat for crap. I have to figure that chat thing out eventually. Anyways, frequencies. Frequencies, what it does is if we parse the input, it tells you, okay, the number 4 appears one time, right? 3 appears 3 times, 5 appears 1 time, 9 appears 1 time. Thanks, some Caleb, for letting me know. I wonder if that's the Caleb that I know or not. We'll see. Right. So this is basically the whole of what part 2 wants you to do, right? It wants you to count up the frequencies of the thing on the right. And it is. Nice. Thanks, Caleb. Some of the things on the right and then go through the things on the left. And sum them? Wait, map them and then sum them, right? Okay, we could get real fancy here if we wanted. Let's do something fun. I think this will work. Let's try. To parse t dash 2. Oh, fun. Let's see what this does. Oh, what happens if it's not in there? What happens if it's not in there? Oh, 0. Okay. Fudge. My little trick doesn't work. I mean, this is silly. I'm gonna do the thing that I should have done in the first place. I'm gonna do get R0, get RG1 0, right? There we go. Get RG1 0. Part 2 parse. Oh, and then we need to sum that. To 10. That doesn't look right. Oh, I didn't do any multiplication. Good lord. Okay, so we get RG1 0 times. How's it? It's the G1 times the number of times it appears, right? It's 31. 31. That looks right. This looks reasonable. What if we do part 2 parse of that? Well, it ran. It did run. If it runs, it works, right? That's what Clojure does. Boom! If it runs, it works. You know it does. That's exactly right. Take that, Haskell, people. If it runs, it works. Every time. 100% of the time. All right. Let's look and see what the Advent of Code crew says about this. Let's see. The crew. If you're not in Clojurians, you should be in the Advent of Code room. And there's always a massive thread of solutions where you find out what other people did and you find like the very best ones. What I'm looking for, okay, let me just skim through these really quick. Yeah, it's just fundamentally the same thing, right? Frequencies, yep, same thing. somebody did a read string that would have actually worked. We could have read stringed all those numbers. That would have been fine, actually. We always have the canonical give good names to things. Not exactly on that team, but it does work. Let's see. I'm looking for people that I know. What happened here? Felipe did Haskell. Felipe, please. Kill me, man. Yeah, you can see they're using the same trick I use. Frequencies, this is literally the same thing. This is what sum does. Oh yeah, Shandy. Shandy is what's up. If you're ever wanting to like see good Advent of Code solutions, Shandy is your guy. All right, let's see what he did. Apply list. Partition 2. Okay, read ints is a thing that he already has, and he partitions them by 2. So he reads back out the list. He makes all the ints. Okay, that's what he says. Sort, map. Does this work? Map sort. We'll sort by the first, followed by the second. But I thought you had to sort like at this point. Huh. I mean, I don't question Shandy, but I'm not seeing how this works exactly. I feel like this is going to sort the tuples by the first, followed by the second. But you wanted to resort. Does it even matter? What did we do with these numbers? I forgot. What did we even do with these numbers? Sort that, sort that. Yeah, absolutely the difference. Yeah, I'm missing something. Because I don't think this will sort in the same way that I sorted at all. And this is the only sort that I see. No. No. I don't get it. I would have to play with this to figure it out. But I believe that it works. And his stuff is always so concise. He always makes something that's that I can read, but is very concise. So you can see mine is 28 lines, and his is 19, literally almost 50% shorter. Well, he cheated. This cheats, right? Like, it's not quite fair. All right. First, he transposes a list of tuples into two lists of nums. Transposes. Oh. 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 Is that try apply map vector list of tuples. Okay. All right, let's see it. I mean, I know what this will transpose, right? That's what this will do. So, but this is going to be 3. In our example, it's going to be 3. I was kind of leaning toward not figuring this out, but now you got me. 3 4 4 3 2 5 1 3 3 9 3 3. All right. Wait. List of tuples, right? It's got fudge. Got to do this number. I see. I'm kind of seeing what you're saying though. Right. This makes the left list and the right list, and then he sort. Okay, that sort applies to the full list, and then he untransposes it here. Right. This apply map we'll put it back. Yeah. So the thing that comes out of here isn't the tuples that I was thinking of each row. It's the columns, right? And then he sorts the columns 1 and column 2. This map applies to 2 columns, and then he transposes it back and sums them, right? Classic Shandy. So classic. He's so clever, man. get rid of my puzzle input. The guy who runs AOC doesn't like it when you like store the puzzle input places. So I try not to. I forget all the time, but I try. I do try. All right, it's 11:35. We got plenty of time. Let's go. Day 2. Let's go. Okay, fortunately, the first location the historians want to search. Can we see? Here, I'll move it over here. I'll try to keep things like generally on the left, since my head floats top right. While the red-nosed reindeer nuclear fission plant appears to contain no sign of a chief historian, engineers are still there. Okay, I'm just going to skip this. The usual data, your puzzle input, consists of many reports, one report per line. Each report is a list of numbers called levels that are separated by spaces. For example, okay, this example data contains six reports, each containing 5 levels. The engineers are trying to figure out which reports are safe. The red-nosed reindeer safety systems can only tolerate levels that are either gradually increasing or gradually decreasing. So, a report which only counts as safe if both of the following are true. The levels are all increasing or all decreasing. Any 2 adjacent levels differ by at least 1 and at most 3. Okay, so all decreasing by 1, by 2, by 2, by 1. 1, 2. Okay. Huh. Okay, this is easier than the first day, right? Like, can we agree to that? This is like out of order. This should have been day 1. Well, I don't know. We'll see part 2. We'll see what part 2 holds. But right now, I am thinking this is easier than day 1. Hang on, let me see what my puzzle input looks like. Close out of this one. Close out of that. Oh, they aren't even. Interesting. Interesting. Okay. All right. So stir split lines. Map. We're gonna do the restring thing? You wanna get crazy? That'll return just a bunch of, wait, no, it won't. It has to be in a vector. You have to do silly things to make that work. Do we do the silly things? Let's just do crazy. It's Advent code. What is Advent code without a little fun? Right? Boom, boom. Def T is that. So now I should be able to, oh, that's such an annoying bug. Parse T. Okay. And so part 1, wait, what do we have to count the number that are safe? Okay. Do I have a count function? Ah, why would I do that? Right? Count. Filter input by. I see where this is a little trickier now. You can't just like say, hey, is it decreasing or increasing? There's a few ways I can imagine doing this. Like we could just say, hey, they're all increasing and then check the diffs in 2 separate steps. Or we can partition, like make a sliding window and look at each 2 numbers and do that check on a number by number basis. I am gonna conjecture that doing them in 2 separate things, just doing a, hey, are these all decreasing or increasing? And then looking at their diffs, I'm going to conjecture that that is actually the more efficient, like less time intensive thing. But I like the idea of partitioning because I like sliding windows. So this here, let's just show you what this does. Not filter, this map. Right, so we have this is the list that we have, and it goes 7 6 6 4 4 2 2 1, and then the trailing one is just 1. I don't know if we want partition 1. I think we just want partition. Yeah. Right. And so you get to consider each tuple of the list in isolation, right? Let's see. So don't partition all, just partition 2 1. And then, well, we want to do like every A and B. For every pair of A and B is, oh, this doesn't work, does it? Yeah, you have to do it in 2 passes. Yeah, never mind. This doesn't work. This doesn't work. It's either, that's not a macro, is it? No, okay. Either that is true or that is true. And, right, it can't be equal. Right. They have to differ by at least 1 of those 3. And, how do we do this? I guess we could still do that partition thing. And then we subtract, take the absolute value of the difference in every one of those. This is the diff, right? Every one of those is between 1, I guess, and 3? Most 3, 4. I guess we can do, this is word for word what the problem says if we do equals there. Does this just solve it? Do we even have to do the first check? Because if the difference is, well, no, it doesn't make, this doesn't make sure that it goes up or down, right? That they all go up or they all go down. Yeah, those are 2 separate checks you have to run. Let's see what this returns real quick. What? That through? Okay. Lazy C cannot be cast to a number? Let's raise this real quick. Look at that. That's the offender. Oh, wait. Apply. I should not do this. Okay. Let's make this legible. A, B. The difference of A and B and the absolute value of that. All right. Got too cute. And then we're going to check if every one of those. Hang on, let's see. Let's run this again. Parse T. Right, so we have two that look good, and in our example, two are safe. All right. In our example, two are safe, and the count of, so part one should be good. Parse of, but part one of parse T is 2. Let's take our puzzle input. Copy. Parse that. Nonsense. 306. Submit. Boom. Easy. All right, here comes the fun part. The engineers are surprised by the low number of safe reports until they realize they forgot to tell you about the problem dampener. The problem dampener is a reactor-mounted module that lets the reactor safety systems tolerate a single bad level in what would otherwise be a safe report. It's like the bad level never happened. Now, the same rules apply as before, except if removing a single level from an unsafe report would make it safe, the report counts as safe. Okay. Right. Ugh. Don't love any of the options that I'm seeing. It's like you want a stateful filter, you know? But filter isn't stateful. Like this is, I hate problems like this because it's like you can feel like there is an abstraction there to use. There's some function that theoretically would do exactly what you want, but it's not in the standard library for sure. So you end up having to do the less fun thing, right? So this is gonna look. Wait. You can't just bah. Well, it's a little. Okay. I felt like there would be an abstraction that did it, but I don't think there is. I totally forgot that, you have to consider this rule, like they all increasing or they're all decreasing. In addition to this, you're allowed to remove the diff, one diff that is too high, but you also need to say, oh, if you remove this, then now this is true, right? Oh, oh, oh my. You have to do the whole check. You have to say, hey, if this is removed, do they still all increase? Do they still all decrease? Oh, team. I think The only thing that's coming to mind is the brute force, right? I think you can't fix too high a diff. It'll just get bigger. You can't fix a too high. Oh, you can like do an like we say. Is that true? If it's like plus 100. Uh huh. I think I see what you're saying. Yeah. The only thing I'm seeing is like the absolute brute force method, right? Where it's just like, hey, take the row and remove item one, remove item two, and just run all the checks. Like either the row itself is good, or start removing one number at a time, and then run all the checks, like this, like pull this out and run it on each row, with removing one number at a time. I don't know. I'm sure there's a clever way to do. For every one of these, there's always like a clever way to do it. All right, let's do the dumb thing. I don't know what else to do unless somebody in chat has a better idea. I don't know what else to do. There are a lot of functions in CLJ Core. The other day I found out about RSeek. Yeah. RSeek's great. Maybe there is one made just for this problem waiting to be found. Yeah, I mean, I felt that way about this part. I was like, oh, you just remove the first diff that's too big. I mean, Caleb pointed out that that doesn't quite work. It felt like that was the direction that I wanted to go, but I there is some math trick here. I almost guarantee there's some, like, if you know enough algebra, there's a math trick here. But the computer part of me is just like, well, just brute force. How many are we talking? I mean, that seems doable, right? Removing for that number of rows, removing one element. It's not uh like quadratic or anything. It's not n squared, right? It's just n, the total number of digits that we have, Ish. A little less than n, probably. Okay, let's just do the dumb thing. Like, so we'll call this what? What's it called? Safe? Row. This is row. Well, this is ooh, actually, do we do this? Is it like this? Yeah. Save. Let's double check. 306 is the right answer. We didn't mess this up. 306. Okay, good. All right, so part 2. We need a way to say we want to filter. This is not a Freudian slip. I don't know what it is. I 50% of the time type filter Fitler. Like, I don't know what it is. But it's a solid, like, I don't know, like 40-50% of the time that just comes out of me. I just did it again. Filter. And now, like, knowing that only makes it more likely. It's one of those things, it's in my psyche now. It's messing with my head, man. All right. Filter in to where the row is either so we just want to remove one item at a time, right? Remove one item at a time. There's not like a remove nth, right? Like, that's, and these aren't vectors. We could make them vectors. Remove. Yeah, that's not a thing. What's the easiest way? Like, is it take and drop? Is that what we got to do? No, so it's like take. Yeah, take the first few, drop. It's like a split, right? But if I split at 0, uh-huh. So we do like a range. Split at I. And then what, like, but last the first thing? And concat them together? Let first and second concat but last. And the second? This is stupid inefficient. I know there's a better way to do this. For sure, for sure. Hang on, let's see what this returns real quick. This feels so bad. Okay, part 2. Parse T. Okay, it does this, and then it drops the 7, and then it drops the 6, and then it drops the 4. Yeah, 4 is gone. And then it drops the 2. Okay, but it does it never drops the 1. That's a problem, right? I was wondering about this. Wait, ink that. Get rid of this. There we go. Now we got one more, and then it drops the 1. Okay, so this produces the list that we're interested in for row, starting with the whole thing, which is exactly what we want. So check the whole thing first. And then we want to, what, sum. I never know what to do here. Sum save. Because we're just going to do a filter, you know? That we don't need to return output. So it's our sum of that safe, right? Okay, I have 4 rows that are safe. 1, 2, 3, 4. And it's 7, 6, 1, 3, 8, 6, 1, 3, right? 7, 6, 1, 3, 8, 6, 1, 3. Yeah, this looks like it returns the right thing. Yeah, none of this feels good though. Okay, let's do part 2. Oh, we want then we want to count, right? Part 2. What was our answer to part 1? Right, it is more than part 1, which is a good indicator. And boom. No sweat. 2 AOC solutions less than 1 hour. Overly verbose. No sweat. Okay, let's see what the dealio is. Come on, just put them in the thing. I don't want to click. Don't make me click. Let's see. Safe. We did a safe. Uh-huh. Uh-huh. Oh. Wait. Oh, that's clever. Right? I Jimmy McNulty. I will consider uploading them to YouTube. I put the chat on the screen. I've done this. I did this in 2018, something like that. I did this a number of years ago, and I have the videos, but I don't have the chat on the screen, which I found really irritating watching them back. So I put the chat on the screen specifically for the video, which I did not record. No, I bet I can download it from Twitch, but I didn't record the video. Tomorrow I will record the video, and I'm hoping maybe this one I can get from Twitch, and then I'll have the chat on the screen so that people who watch it later on will be able to see the conversation that happened as well. So yeah, that's the intention, Jimmy. So we'll see how that pans out, considering my level of like, yeah, I have no idea what I'm doing. We'll figure it out. So this is good. This is good. So I knew that there was like a thing here where you could look at the diffs exclusively without having to do the. So what we did was this check separate from this, right? And Norman figured out how to just do a couple of passes over diffs. And then, okay, how does he do this? He does take, draw. He does this is split. Okay, so instead of but last, he adjusts the split. Well, he doesn't split. He adjusts the drop part of the split manually, basically. But he does it the same way, range 0 to count. Super safe. So he doesn't have to do this, I think. Oh, he does. Right. So okay, this is funny. When you drop from the first one, you don't have to do this check separate, because the first thing that you're going to come up with when you do this here, if y'all remember, the first thing in row, I gotta do it up here. 1, 2, 3, 4, 5. Oh. Is the full row unchanged. So I did but last on the first thing, you get the full row unchanged. The way he did it, you have to do this check separate. You have to check the line by itself and then check the rest of the lines. But he does some. So this is fundamentally the same as ours. Yeah, some differences in how we phrased certain things, but for the most part, let's see. Yeah, no, that's Maravitas has the right idea. This feels terrible. Like when you're doing it, it's like, this is gonna be so slow. Oh, let's see. Random one. Thrash this one. Got the right answers. Elegantly brute force. Yeah, everyone has the same feels. Everyone has the same feels. I don't like this. I don't want to brute force this. All right, Shady. Let's see what you got. Yeah, the same trick, right? Same trick with this. Intervals is hiding some stuff. That's hiding some stuff. Cons. I don't know what this does. List remove. I think he's hit the thing where you remove one thing at a time before. Yeah. That's what this does. Yeah, this removes an index. Let's go look. Shady. Is it list? C. Call util. Call util. List remove. Take drop. Yep. Yep. Oh. Okay, yeah. Take drop with the ink on the drop. Yeah, he does. It's fundamentally the same thing as the first. This is basically the exact same as the first one that we saw, actually. Basically the exact same as the first one we saw. Which I guess is if Shady didn't come up with an elegant algebraic thing, maybe one doesn't exist, but it felt like one should exist. What about Gaskins? What do you got, Gaskins? Oh, we did it with the loop recur. Ooh, ouch. That hurts. Do not like having to drop to loop recur. We have remove nth. Yeah. It's a version of that. Mm-hmm. This is really similar to ours because we did this. I don't know. I find this a funky phrasing, passing some functions here for this when you could just enumerate them explicitly. I tweeted today. What was it? Tweet I said today. Tweet deck. I don't know. Twitter. Potium. I was like, Clojure is the most static of the dynamic langs. That's what I feel about this. Is like this is making a dialang out of something that could just be static, right? It's like just do the checks, explicitly instead of passing functions around for this one. Personal preference. It's not. I would not write this up in a code review. Right? If somebody asked me to code review this, I'd be like, that's not how I'd phrase that, but have fun, Oh, are there any others? Does anybody in chat know of one worth looking at? Or do you have one that you've done that's worth looking at? Keep indexed. This is all really similar. Got a little clunky here. Yeah. So there's a tendency in the Clojure community to do things like this, right? To evaluate something to like pure data. I'm pretty mad about it at this point. There was a time I had a phase in my Clojure career where that seemed appealing, and that phase is past. All right. Well, if there are no more suggestions for solutions to look at, we can call this stream a success. We got through. We did everything we wanted to do. Thank you, anybody. Thank you all for stopping by. My goal is to do this same time tomorrow, 11 o'clock, and we'll pick up where we left off. All right. Have a good day. See y'all.